Welcome to Help Your Math. This is one of the first in a series of 2 videos. In this video, I'm going to show you how to do the work by hand, manually. And then I'm going to actually do the calculations. So if you wait for the video to end, you should see how to do the calculations and how they're described in the video following directly after this video is over. All right? All right. Hello. Welcome to HelpYourMath.com. In today's problem, we'll be working on a compound interest formula. And to do compound interest, there are a few values that we have to understand and interpret to understand how this works. Firstly, the A in our compound interest formula, which we see here, which is A equals the principal value times 1 plus the rate divided by the number of compounds raised to the power of the number of compounds times the number of years, right, which is the time, T. Now, again, A represents the accumulated amount of interest plus the investment. P represents the principal amount, while R represents the interest rate, and N represents the compounding period, and T represents the time in years. Now, the thing that's really ambiguous about these kind of problems, besides your rate of interest and also your investment amount, which is also considered to be a principal value, is your number of compounds, right? Besides the time in years. These are 4 variables that work between each other to make the accumulated amount. And the same way there are more than 4 variables here, if there's 5, we can always solve for one of them if we have the other 4. For the most part, when we're doing compound interest, we're usually solving the accumulated amount. And so in this video, what we're going to do is we're going to solve a compound interest problem in 4 different types of ways. And those ways are going to be monthly, quarterly, semi-annually, and annually. And we're going to see the difference in all the 4 compounds and what they mean. And so here we have a question, and the question says, find the compound interest for a $1,000 investment with a 2.5% interest rate over 5 years if it is compounded first monthly, secondly quarterly, thirdly semi-annually, and fourth annually. And so we're going to do each of these to see which one produces the greatest amount of compound interest. And so we'll be able to determine what's the wisest investment type to make if we were offered these 4 offers. And to begin with, we see that the only thing that's different about these is the compounded amounts. And so our first step is going to be to identify how these compounds are different, right? And we'll explore this compounding period phrase. So the first compound phrase we see here is the monthly. Now, the compounding periods are always referencing a number. And monthly compounds are telling you how many times does something compound in a year. And here we see monthly, which month represents every month of the year. And we know that there are 12 months in a year. So whenever we have monthly compounds, our N is going to become 12. And the same way when we think about monthly compounds, if we think about quarterlies, we're going to think about what quarterly compounds are, and we think what a quarter of a year is. And what quarterly then represents is 4, because there are 4 quarters to every year, right? Like especially in business, we all know that every quarter represents a different season. Now for semi-annually, right, for semi-annual compounds, it's very similar to quarterly. Semi-annually means every half year. So this represents 2 compounds. And finally, we have annually, in which the root word of this is annual. Annual means just once every year. A good example of annually is income taxes, right? Income taxes happen once a year, right? Now, to explore these different compounds for each one of these different problems, we'll have to use this formula 4 times. What's changing in each of these are going to be our compounding periods N. So this is going to change the exponent on what happens inside these parentheses as well as what happens to the rate, since the rate is going to be broken up into several components during a year. And that's what the difference is for all of these compounding periods actually, right? So if we see a 2.5% interest rate on an account going and increasing the account, we know that that interest rate is then spread over, if it's monthly, it's spread over 12 different months, and each month you're going to get a percentage of that rate, not the entire rate every month, which some people think. However, if you're getting an annual interest rate, that interest rate kicks in once every year at the full percentage of the rate. So there are pros and cons to it, but let's see which is the best investment to make if we were to make one, right? And so here we have our formula. We're going to start with monthly compounds. So our monthly compounds of n is going to be 12. As far as everything else of the problem goes, we know that our principal investment is going to be P. And so P becomes 1,000. We know our R is 2.5%, right? So we take R as a percentage. We're going to convert this percentage, and to do that, we put the percentage over 100, and we simply divide it with our calculators, right? Just type them in, and here you're going to get 0.025. Also, if you're not doing this work with a calculator, you're going to need one, right? Because the numbers are way too great. There's no way anybody could just do this in their head unless you've been a financial pro for like your entire life, right? And here we have our time in years. We see the time is over 5 years, and so our T is 5. And we have everything we need to know, right? We have 3 out of the 4 variables that we need to know. The one that varies is n. So n1 is our monthly compounds, right? And our monthly compounds, let's put n with a subscript of m here. That's 12. N with a subscript of q. That's going to be 4. N of a subscript of s for semi-annually. That's 2. And an n with a subscript of a for just annually, right? And we're going to do 4 formulas for each of these. So what I'll do is I'll subscript each accumulated interest with a subscript of the letter. So our first one would be the monthly. So A of M would be the principal, which is just $1,000, times 1 plus the rate of interest, we see here 0.025, over our number of compounds, of course, for N of M is 12. And here we're going to have 12 times 5. And what we want to do is we want to resolve these things. Now, the best way to do this, in my opinion, since you're using a calculator, is always to do this. Know how to write this work on a calculator. First, let's simplify whatever we can, and then we'll resolve whatever else is left. Now here, we have one small kind of a problem. If we solve this on a calculator, we're going to get a repeating decimal. And the problem with repeating decimals when you're using calculators is you can't get an exact repeating decimal without having the actual fraction. Lucky for us, we're using a calculator today, and the calculator will do everything. So what I'm going to do is I'm going to try to get this power to be a solid number. And once I have this as a solid number, I'll go and I'll calculate everything from here to here with the exponent and get a number with at least 8 decimals or 7 decimal places. I think I'm going to go for like 8 decimal places, maybe 7. We'll figure it out as we go along. So let's write the formula for each one of these so that we could get to our calculating stage and actually see what's the best kind of compounding period to work with. Second compounding period is quarterly. And we know this is $1,000, right? Missed the one here. $1,000, 1 plus the interest rate divided by the number of compounds. And for quarterly, again, we have our quarterly compounds at 4. So we're dividing this by 4. And then we have n times t, the number of years is 5. The number of compounds is 4. And we'll simplify this in a second and get to it on our compounding phase. The next one is semi-annually. And here we have, again, $1,000. We have 1 plus 0.025 over 2. This is a little easier to calculate. And here we have 2 times 5. And finally, we have A of A. And this is 1,000. Oops. We have 1,000 times 1 plus 0.025 over 1. And we have 1 times 5. Now let's rewrite these so we have solid powers and then we can get to the calculation phase. So here we're going to have 1,000 times 1 plus 0.025 divided by. And here I'm just going to rewrite this so it looks exactly as it will look on your calculator. And we're going to have 0.025 divided by. Here we have 12. And the new exponent here is going to be the power of 12 times 5, which gives us 60. All right, so this is what it's going to look like when you're typing it into your calculator. Remember, this is a calculator. This is what it reads out as on any calculator you have, whether it's a scientific or a TI or a graphing calculator that's a Texas Instruments, right? For the second one here, and the reason why we're doing it this way is because this gives us a repeating decimal on our calculator. We need that to stay the same on our calculation, and this will sort of fast forward us to the result. For the second one here, we have 1,000. We have a parenthesis of 125 divided by 4, right? Now this may give us a solid number. Let's take a quick look at what that number would be. So we have 0.025 divided by 4. And that actually does give us a solid number. It's going to give us the number plus 0.00625. And this again, we have the exponent. This is the result of 0.025 divided by 4, which is a lot nicer for your calculator. And here we're going to have the power of 20. So we're going to raise this to the power of 20. And remember, this will only work on a scientific or a graphing calculator because you have the arch to raise your exponent. If you don't have the arch and using a more basic calculator, you're going to have to run this part first and then multiply that by 1,000. All right, now the third one here, we have 1,000. We have 1 plus 0.025 divided by 2, which gives us 1 plus 0.0. When we divide this by 2, we get 0.125. And our exponent is going to be the power of 10. So we're raising this to the power of 10. The final one here, since we're dividing by 1, it pretty much stays the same. And we're multiplying this power by 5, the 1 by 5 for the power. We're going to just have 1,000, parenthesis 1 plus 0.025 to the power of 5. And that one plays out pretty straightforward, right? Now let's start taking a look at what our calculations will do. In our first calculation, we're going to raise this to the exponent here. And we just run this on our calculators, right? And we're going to have 1,000 times, and raising this to this exponent gives us 1.133011. Now multiplying these two together, we're going to have 1,133 and 00, and the 1 just falls off because we can't round the 0 to any number. This has to be 5 or greater to get a value. So our first investment with monthly compounds gives us $1,133, which is a pretty good investment. Let's take a look at our second one, all right? Now here, when we raise this 1 plus 0.00625 to the power of 20 on our calculators, we're going to get 1,000, parenthesis 1.132777. And I'm going to stop here at the 7th position because I'm going to round this to the position of cents. And what happens is these 3 decimals, these positions are going to move this decimal 3 positions over. And I'm going to use this 7 to round that 7 up to anything. Or actually, I won't even need that 7 at all, right? So what I'm going to have here is I want to get a number in a dollar format, right? Rounded to the nearest cent. So multiplying these two, I get $1,132. And here I have a 7. And I'm rounding the 0 position, right? Because you're probably reading this as 070. And we want to round this to the nearest cent. So rounding this to the nearest cent, the 0 becomes a 1. And I get this rounded to the nearest cent. And this is exactly $1,132.71. And for the next one, I'm raising this. I'm doing 1,000 times 1 plus 0.0125 to the power of 10. I'm going to start by raising this sum to this power, keeping the 1,000 outside. And inside, what I'm going to get is 1.1322708. Now when I multiply this, again, the decimal shift is 3 positions, so it goes from here to between these two, right? It goes over 1, 2, 3 times. Or you could just calculate this and get the same result. And we want to round this to the second position on the cents, right? So I'm just going to take 3 decimal places after and round it. So I have $1,132.27, and this becomes 1, right? This 0 becomes a 1 because of the 8. And now I'm rounding to the nearest cent. Actually, we wouldn't even bother with it because it's just a 0. We won't round the 7 because it has a 0.8 after. This is not 5 or greater, so we just leave it as it is. So this becomes $1,132.27. As for the final investment with annual compounds, here this one's pretty straightforward. We're just taking the $1,000 and raising it and multiplying it by 1 plus 0.025 raised to the 5th power. And here this is pretty straightforward. Most calculators will do this easily. And when we raise this 1 plus 0.025 to the 5th power, we're going to have 1.1314082. And now multiplying these two again, we shift the decimal 3 positions over, and we're going to have 1,131.4082. The 8 is 5 or greater, so we're going to round this up, and we get $1,131.41. And now going back and looking at which is the best number of compounds to have in a year, we see that having 12 compounds generates the most interest rate, right? The most compound interest. Whereas annual interest only compounds once. The monthly compound actually gets you more generated, right? And thank you. All right, now when you're calculating this by hand, and your calculator's actually not by hand, what you want to do is you want to calculate the inside of the parentheses for each problem. And we remember from the first problem we saw, we had 1 plus 0.025 divided by the number of compounds, which was 12. And to do this, what you want to do is you want to press enter on your calculator before you do anything else. When you're following the order of operations, what happens first is the inside of the parentheses. So here we'll press enter. When we press enter, we get this number with a repeating decimal, which I mentioned in the video. And the best way to deal with this repeating decimal is not to cut it off. So we just want to use the calculator, and here's the arch that we heard about earlier on the board while I was writing. So we're going to raise it to the power, and here we see it takes the answer and it puts it to the power of the exponent, and here it's going to say the power of 12 by 5, which is 60. And so when we do this, we're going to get the amount of what the percentage of the rate is going to be doing after that many compounds. And now all we have to do is multiply this by the $1,000. Pressing enter here gives you the amount, and here we're going to round this up to the nearest cent, which when we round it off gives us 1133.00. And that's our first amount, $1,133. All right, moving on to the next one, we had quarterly compounds. So we have 1 plus 0.025% divided by 4. And this again we're doing first because it's in the parentheses and the order of operations tell us to do this first. We get 1.00625, and we're going to raise this again using the arch. And if you don't have the arch on your calculator, that means you're using a calculator that has y to the power of x, right? Or x to the power of y. If you're using any of those scientific calculators, make sure that instead of using the arch, you're using that button and you're pressing it. And after you press it, you're going to put in your new exponent. Now on this one, remember, we have quarterly compounds for 5 years. So the amount of compounds you have for quarterly compounds for 5 years is 4 by 5, which is 20. Then we press enter. We get the rate amount that we're going to have for the 20 compounds over the 5 years. And we're going to multiply that by the $1,000 investment. And here we get $1,132.70 with the remainder there. So what we're going to do is round this one up to the nearest hundredth, right? And the hundredth is right before this 7. So the 0 here is going to become a 1. So our amount is $1,132.71. That would be our total amount of compound interest for that problem. Now moving up to the semi-annual, we have 1 plus 0.025, the percentage of 2.5% is 0.025 divided by 2. And that gives us this, 1.0125. And we're going to raise this to the power of 10 because 2 times 5 is 10. So we're multiplying that by 10. We press enter. Actually, we're raising that to the power of 10. I'm sorry for that. And we get this. This is the rate that's applied to the initial investment over the 10 compounds that happen in 5 years because it happens semi-annually. In 5 years, if we compound twice a year, there are 10 compounds in total. We multiply that by 1,000 and we get $1,132.27 when we round it to the nearest cent because we can't do anything to 7 if we have a 0 next to it. It has to be 5 or greater to round it up. So that would be our total compound interest for 5 years with semi-annual compounds. And finally, we have the annual compound where we have 1 plus 0.025 divided by 1. And this stays the same. We should have 1.025 when we press enter. And now we've raised this to 5 years of compounding annually, which gives us just 5 compounds when we multiply 1 by 5. And this then gives us our amount that we're going to raise our principal by. And we multiply the principal by the rate of what we get over 5 years for annual compounds. And this gives us $1,131, and we round to 41 cents because the 8 is after the 0 and 8 rounds the 0 to a 1. And that's how we use our calculators, all right? Thank you.